Okay. I welcome you on the lecture series of electric power quality. Today we are going to discuss the principle of over voltage protection. You know that why these over voltages are produced in the system. So because of lightnings, so these over voltages are produced in the system. Okay. So how to remove these over voltages from the system? Okay, how to protect our equipments, our consumer equipments, our industrial equipments from these war voltages caused by the lightning. Today we are discussing all these things. Then what are the different devices to protect the war voltages from the lightning? Nothing but the our devices. You can see this today. We are going to see all these things. So, what is the principle of war voltage protection? What is the principle? The basic principle of war voltage protection. Nothing but it is very simple. Very simple. So, to protect the devices from these war voltages, then we can consider the devices are nothing but the loads. Which type of loads we are going to consider? Okay, we are talking about the devices is nothing but the loads. As I said so many times. So one protective system is not sufficient to protect the all the type of the loads. Depends on the loads or load characteristics. We are going to protect the system. Okay, based on the loads only. Okay, so the what is the principle? First principle is, what is the first principle? To limit the voltages across the sensitive insulation. That's nothing but the load insulations. To limit the load insulation. To limit the load installations. Then second one. Then what is over voltage protection? Now see this, you know that you are not at all minimize these over voltages or these currents or lightning currents. The only possible way you can divert that current. Okay, divert the surge current, or you can also call it as lightning current away from the load. That is the second principle. Okay, then what is the third one? To block the surge current from the entering the load. The block means here these are the similar. Whenever you want to divert the current, that may similar to the block. Now this is the important one characteristics. Bond grounds together at the equipments. Now I will tell you in the coming slides what is this bond grounds to together to protect the equipments. Then this one you can see this reduces the surge current from flowing between the grounds. Okay, reduces the switch currents or surge currents to flowing between the grounds. The next one see here, low pass filter using limiting and blocking principle. Create low pass filter using now all these principles. Now we are going to see now all these points. You are going to satisfy all these points now today. Okay, this one, this one, this one, this one. Okay, we are going to satisfy all these points today. Okay, now see that. So now see this one thing. Now see this lightning. Now see this lightning. Some over voltage protection. So this is the some basic diagram to demonstrate the over voltage protection. Some basic diagram to demonstrate the over voltage protection. Here see what is the so you know that for all over voltage type of protection we are using the mainly the surge arresters. Surge arresters. Or you can also call it as a surge diverters. Remember, surge arresters are surge diverters. The main function of surge arresters or surge diverters and transient voltage suppressors. This is one of the another device to limit the voltage. Remember, to limit the voltage that can appears between the 2 points in the circuit. Okay, now see this basic diagram. See this basic. This is the source, power source. This is the line. This is the line. Remember, this is the line. This is the load. They can assume it as sensitive, whatever it may be. You are assuming sensitive load or whatever the load it is. When the lighting it may fail you. Any of the equipment, whether that is a sensitive load or critical load or non-linear load or whatever, any of the load. Okay, for suppose there is a lightning. See this, there is a lightning here. See this, hit by the any of this line. Now see this, in between the source and load. See, in between the source and load. See here, see a diagram. Source. We already seen this last class. This is load. This is load. This is the impedance character Z. Some impedance Z. I'm drawing only single line diagram. You can see this. Yeah, I'm converting this into this line. So if there is any lightning is hit by this line, what will happen? So in the substation, remember, in the substation we are using, now see this, we are using some surge arrestor or surge diverter to minimize this lightning current. So that is this one. That is this one, first one. In the substation. Okay, in the substation itself, we are providing one surge arrestor or surge diverter to minimize the surge currents or lightning currents. Okay, now see this connection. Now see this connection. Now see this connection. When we are using this surge arrestor or surge diverter in substation, we are connected into the ground. Now see this ground. Connected to the line to the ground. Line to the ground here. Line to the ground here. See this line to the. This is the line to the ground. This is the ground. Ground. Line to the ground. What is a basic principle of surge arrestor? It can divert currents from a line to the ground are nothing but the low impedance paths. Okay, now see this. Lightning currents are seeking. Now see this. Now see this. Lightning currents are seeking ground and basically divided according to the ratios of the impedance of the ground paths. I will tell you the meaning of this. What the device, what surge arrestor or surge diverter is do is it can divert the see this. It can divert the huge amount of such currents or lightning currents from any of the phases. Remember, any of the phases. For suppose it is a three-phase system, phase A, phase B, phase C, or whatever it may be, any of the phases, or you can also call it as line to the a ground. Remember, not the neutral, a ground. This is the line. You can assume in the single line diagram. This is the line. This is the neutral. Now see. There are a lot of now see this this is the surge arrestor. Now see this symbol is the surge arrestor. Now see this is the surge arrestor. Okay, there is a lot of research is there where you are connecting the surge arrestor from line to the ground. Which place or which ground? What type of ground you are choosing? Whether the ground it has low impedance or whether the ground has low or high impedance path, it provides the low impedance path, that ground, or it provides the high impedance path, or that ground is nearby any water sources are there, or any other particular some moisture type of the environment is there. You are considering all the factors while you are grounding the suggested line to the ground. Because why means because this ground will provide the low impedance path. Whenever that ground is provided the low impedance path, then only the large amount of such current is from flowing from ground to the from line to the ground. There is some amount of, but you know that there is no ideal cases, scenario cases are exist in the outer side. There is, even though we are choosing the best ground, nothing but low impedance path, there is some amount of, remember, there is some amount of impedance is present in the ground. Impedance, nothing but Z impedance, R plus JXL. There is some amount of impedance is present in the ground. Because of that impedance, the voltage and the surge currents are diverted. Diverted. See this in this direction. Diverted. So it cannot minimize the entire surge currents or lightning currents produced by the lightning. Because of some ground impedance, some amount of surge currents flowing into the load side. See this load side. So you understand. I think you are understand this one. Okay. So this is the, now see this. So this is the first one, surge arrestor in the substation. We are placing this in the substation. We are placing this in the substation. So now looking this surge arrestor is connected in between the line to the line to the ground. Remember, line to the ground. So while choosing the ground is also very important thing here. That you whether you are choosing the ground, that ground must be a low impedance path, that provide the low impedance path. Even though it provides the low impedance path, there is some amount of impedance is offered by the ground. I said choosing the ground is very important, whether it is a wetland or whether it is a dry land, whether it is a watery land, whatever it may be, depends on that one. The impedance offered by the ground, it changes. We are choosing always a low impedance path ground. So due to some amount of ground impedance, some currents are diverted into this line towards the load, towards the load. At the same time, before it going to the load side, there is some low pass filter here. Nothing but low pass filter is nothing but you are not at all consider the another equipment. Here the line itself, it has some impedance. See, okay, that you can call it as the some low pass filter. You can assume it as low pass filter. The line, this is the line, remember, this is the line. Line has some impedance, you know that the line has some impedance. That impedance will act as a low pass filter. It can eliminate the some frequencies. Even though that eliminating, it is traveling to the load side. Now see this in the load side also. Okay, in the load side also. Now see this. See this is the second. We are providing and another type of such diverter or such arrestor, but it is connected in between the line to the neutral. Two lines in between, two lines, nothing but one is the line, another one is neutral, not the ground. Remember, not the ground. Okay, now see this. Because of, now see this, now see this, what is this, what is this, I know that. So what is this, now see this fourth point, what is this fourth point? So we already discussed the limiting, diverting, as well as this low pass filter and reduces. Then what is this, what is this one, this point, this fourth bond comes together with it. Now see, now you can carefully observe this diagram, these dotted lines. You can observe these dotted lines, you can observe these dotted lines. An external signal cable, an external signal cable is connected before the load, sensitive load, before the sensitive load. This, because of this cable, external cable, as well as the grounding. Now see this impedance, ground. Now see this ground. They are bonded together. Now see this connection. They are bonded together. It will also leads to some transients or increase of over voltages in the load side. Here the signal cable, nothing but the external cable, when it is bonded to the ground. Now see this, when it is bonded to this ground, a local ground. So the ground, you know that the ground is nothing but a low impedance for nothing but, and such arrestor, a such diverter is also connected to the this ground. Now see this connection. Now this one to the, now see this connection. This one to this one. Now see this connection. Because of this, some amount of load currents are nothing but the surge currents are entering to the sensitive. Okay, you are going to reduce this type of sensitive loads also. These sensitive loads are nothing but these bonded grounds local will produces the transients. Again, the transients in the system. Okay, now see these lightning currents are seeking ground and basically divided according to the ratio of the impedances ground path. As I said, impedances. When you provide the low impedance path, the amount of such currents diverted into the load side is reduces. Choosing the ground is very important. This is the basic principle of over voltage. So one surge resistor you are using the substation side, substation, in the substation. Another, the second one we are using the load side. One is we are using the, one surge resistor we are using the substation itself, and another surge resistor. Now see this 2. This is the 2. This is the 1. A 2 is used at the load side. Now you can see this sensitive load. We are taking it as sensitive load, but in practically, because of this lightning, any type of the load is damages. Okay, not at all sensitive load. We may assume any type of the load here. That is a load, any type of load. What will happen when you are not properly grounding the surge arresters? There may be a flashover of the insulators also. That flashover occurs, the entire power failure will happen in the system. Nothing but that we can call it as interruption in the system. But in these cases, that will causes the over voltages in the system. Even though we are using some surge arresters and our diverters to reduce or to minimize the huge amount of current, and some amount of current is passed to the load. So that current you must be minimized, otherwise the equipment may damage. So that's why we are using this second surge. This is the first case here. First case. You know that there may be a chances that and lightning is hit nearby these loads. Lightning is hit nearby these loads. And that time also this surge arrestor 2 will protect the system from a huge amounts of surge current. Okay. Now move into the devices. This is the basic principle. How to minimize the surge current. What is the bonding effect? What is the impact of the bonding? Then what are the different types of devices to minimize this war voltages? Not only the surge arresters, including the surge arresters, you are also using some another equipments to minimize this war voltages. As I said, the surge arrestor is not sufficient to minimize the entire surge currents produced by the lightning. There are another type of equipments are also needed for minimize this war voltages that will causes to the transients in the system. Okay, there are another devices are also required. So now see this another type of device. So one type of device we are already discussed here: surge resistors and transient voltage suppressors. Both are same. This one. Now we can see this isolation transformers, low pass filters, as well as low impedance power condition, as well as utility surges. You can see this remaining case. Now surge arrestor is nothing but a surge diverter. It can provide the low impedance path to the surge current and it to divert the surge currents to the ground. That is the functionality of the surge arrestor. Okay, now see this one, surge arresters and transient voltage. Now we can also call it as a TVSS, transient voltage surge suppressors. Now see this. What these devices are do here is simple. It can divert or it can limit the maximum voltages that will associated with the light, or simply it can diverting the huge amount of such current. Simple. Now these devices are protect the surge arresters and transient voltage surge arresters will protect the equipment from transient war voltages. War voltages, nothing but lightning will causes the transients. Lightning will causes the impulsive transients. You know that. Impulsive transients. Capacitor will causes the capacitor switching will causes the oscillatory transients. Oscillator. So impulsive transients will causes the lightning. Okay. Now see this. Now how to make these devices? These devices can be classified into cloud bar devices as well as the clamping devices. Okay, clamping devices for a circuits are commonly non-linear resistors. Okay, so to vary the low amount of currents to the war voltages, simply whatever all these things. Okay, so these are the clamping. Then what is the cloud bar device? These are the open devices that can conduct the current during the war voltage transients. This is the cloud bar. So the total elements in the surge resistor and transient war voltages you can divide into the two types: cloud bar as well as the clamping devices. A cloud bar device are normally open the device that can conduct the currents during the war voltage transients. Then what is the clamping device is done? Clamping devices for AC circuits are commonly non-linear resistance. Those are the non-linear type of the resistance that can conduct very low amount of currents until the over voltage is suppressed. Now you can see the next one, isolation transformers. You know that you already see this isolation transformers. So we are considering here two types of the isolation transformers. So it can simply form. Now see this isolation transformer figure here 4.9. See this isolation transformer. See this. It can form the LC low pass filter. This will L. It indicates the inductance. It can has some inductance. There has some capacitance. LC low pass filter. What is this isolation transformers are nothing but a, so it can forms the a filter. So it can filters the high frequencies noise transients as they attempt past one side to the another side. This is the primary side. Primary it can stop the signals, noise signals from primary side to the secondary side. What is the best characteristics of this one? What is the characteristics of isolation transformer? Electrically isolating the load from the system for transients is the leakage impedance. Then what is the voltage notching? What is the voltage notching? You know that notches. See this. Yes, like this. These notches. Now see these notches. See this. Are noises. Can filter by this inductance and as well as capacitor is nothing but the LC filter. LC filter. It can also filter the noises that produced by the system. And second one, it can filters the high amount of frequency noises, and as well as it can also reduces the some notches that is produced in the system. So this is the one type of the isolation transformer, LC filter. This is the another one that is connected to the grounding. Now see here both sides that we are assuming it as a capacitor, nothing but LC, as this side as well as this one and this one. Now see here at one side only you can consider the capacitor, another side you can consider it as a ground. That can form the electrostatic field. That can form the this path. Now see this path. This path of grounding will provide the electrostatic shield to minimize the transients in the system. Some diverted. You know that sudden changes, it will not accept the sudden changes in the capacity. But there is some problem in this capacitors also. A switching transients will also inject it into the second. That is also the some problem. But that switching capacitance events are very low in this case. Now see this low pass filter. As you see this, how the transformer is producing the filter. Now see this. Now this is the L. This is the C. Low pass filter. Similarly, this case. This transformer is also following the LC filter. Now you can particularly you can assume in this case a low pass filter. You know that what is the low pass filter. You already see this in this one, a low pass filter. Yes, this is the low pass filter. See this low pass filter. We already seen this. Line itself is providing some low impedance path to the currents. So it is of now you know that how to frame the low pass filter. Low pass LC filter in nothing but it is the combination of inductance as well as capacitance. They are connected in parallel, series and series inductor as well as the parallel. It can provide the low impedance path to the ground for selected resonance frequencies. You know that low impedances. It can provide low impedance path for the resonant frequencies, some selected frequencies. So this is the low pass filter. Now see this some low impedance power conditioner. One type of another device is low impedance power conditioner. Low impedance power conditioner. Low impedance power conditioners. Now see this diagram. Low impedance power conditioners. Power conditioner. Now see this transformer. Now see this transformer. This is the primary side. This is the line to the neutral. Line to the neutral. This is the ground. Remember, a neutral is different from the ground in these cases. A primary side, this is the primary, this is the second. So why we are using this low impedance power conditioners? We can see this. These are used to interface with the switch mode power supplies found in electronic equipment. Now see this. Where which side can filters? The secondary side. See this. The output side. The output side. Output side. You can filter the transients present in the system are high frequencies. Now see this. The filter is an output side that protects against high frequency source side. Common mode. It has two modes, common mode as well as the normal mode of disturbances, that is the noise and the impulses. Now see the secondary side, how the secondary side is connected. You observe carefully. You observe in this case carefully. You can observe in this case carefully. And secondary side of this transformer, this is the L, this is the N, this is the ground, is connected to the ground. Now see this. Now secondary side, one of the secondary side ground is divided here in these parts, these two parts. Now see these two parts. One side is also connected to the primary side. This is connected to the secondary side to limit the noises that produced in the system. This is the one another type of the utility surge arrestor. An utility surge arrestor. Now see this, an utility surge arrestor. You are already see this one. This is the surge arrestor technologies. This is the surge arrestor technologies. Okay, you already see this surge arrestors, surge arrestors, surge arrestors. You already see the surge arrestors. What is the main function of the surge arrestor? It can divert or block surge currents. It can provide or it provides low impedance path to the surge currents. You understand? It can provide some low impedance paths to the surge currents. So this is the manufacturing different types of the surge arrestors. So your diverting path, this is some line connected. First one, this is the ground connected side. Okay, line connected side as well as the ground connected side are neutral, ground or neutral in this case, or neutral whatever. This is the line connected side. This is the ground or neutral connected side. Okay, to minimize the sparks that is produced in the system, or to minimize the amount of large amount of surge currents, you are using some resistors. You know that resistors. So the gap we can create it. This gap So you're using the this one type of chemical to minimize the use amount of sparks that is produced in the suggesters. One thing we are using here. So one type of chemical is this SiC, then another one is zinc type. So this another one. The construction. These three are constructional differences. These three are constructional differences. Now see this a resistance grade gap structure in this case. Here the second one there is no the type of structure. Now see this a third one it has some resistance grade structure. Now first one you can call it as a gapped silicon garbage. Then second one you can call it as gapless. There is no gap. Whenever you are producing some gaps into the system, so the current surge current is reduces. The path you are diverting the path, you are minimizing that path. Nothing but you are providing some low impedance path. It may causes reduction of the surge current. Now this is some gap type surge resistors. You are using this material, some chemical material to minimize this surge current that will produced by the some sparks in this surge resistor. These are connected line to the grounds are neutral in between. As simply is nothing but the lines. This is the line. This is the load. This is the Z. You are connected suggested in this case. Or you can connect it from the load side. You are connected some suggestors and substation side also you can connect it some suggestors. But the functionality from the load side to the some source side to the load side is different. Here the suggester we are connecting in between the line to the ground. Here the load side suggester most of the cases we are connecting between the line to the neutral most of the cases. Remember, not only the suggesters is sufficient to minimize the surge current. Okay, so this because of this not providing the low impedance pass to the surge current, there is some amount of currents are divert into the load side. So that we can minimize that currents also minimize. We are going to minimize. Okay, so for that purpose, we are using some different types. Those are the low impedance power conditioners, some low pass filters, some isolation transformers. Now see some transformer are nothing but transients causes. One thing you can see the some lightning we are discussing. Then next one lightning causes the impulsive transients. Then second one is the capacitor switching. It causes the some oscillatory transients. Some oscillatory transients. Okay. Now see this some so lightnings will causes the impulsive. A capacitor will causes as see this impulsive. You know that impulsive. Now see this because of lightning at zero instant, a huge amount of voltage or current. Here see this a positive or negative direction at time zero instant will produce. This you can call it as a impulse. This huge amount of these currents are minimized the using such resistors or such diverters or some different types of devices. But before it operating, there is one case here. Before it operating or before it clearing, there is some amount of see this load Z source. Before it clearing such resistor, there is some amount of currents is entering to the line or load side. So before it operating, nothing but operating at the same time because of the ground also some amount of currents that enter into the lines that currents we can call it as a impulsive transients or impulsive trans. So that will happen in the lightning as well as the capacitor switching. You know that capacitor switching. You know that because of this capacitor switching, it will produces some transients, or it will leads to the voltage sags. It will leads to the some interruptions. It is also similarly, lightning also leads to the interruption, and it is not clearing the fault. It will leads to the interruption of the devices. It will also leads to the flashover of the insulators. Okay, there are another capacitor switching transients events to produces the transients. Some switching times. That switching times is nothing but, so for suppose you consider some industries, nothing but some or other education institutions. Our college starts are open at the 9. So on that 9 a.m. we are going to start the capacitors banks. That switching time. So it will cause some transients. Okay, some closing, some capacitor, because of the capacitor location. You see this, we are thoroughly discussed this capacitor locations. From the load side locations, from the capacitor you can assume it as again the substation side, and then on capacitor switching you can assume it as the load side. In the substation side you can use the power factor improvement. In the load side you can use the some uninterrupted power supplies. So pre-instant, then nothing but this some closings, some closing and opening. Transients will occur on and off cases. Transients mainly will occur on and off cases. Some synchronous closings. The next one is the some transistors, some resistors, insertion of the resistors. Okay, whatever it may be, whatever it may be. So when when coming to the over voltage protection, these are the some principles of over voltage protection. Simply you can minimize the large amount of currents that will caused by the light. That purpose we are using the different types of devices. Okay, this is the principle on which side we are going to protect the system. From the substation side you are going to protect the system, at the same time from the load side you are going to protect the system. Usually you know that for lighting purposes, to minimize that lightning currents we are using the surge resistors. But not only that, surge resistors will provide an 100% clearing of these surge currents. Some amount of currents are diverted into the load side because of this grounding. Because of this grounding. Okay. Now you can see this different types of devices to protect the over voltage protection. Remember, this is the one device. These are the devices only to divert or to minimize such currents. All other remainings are this one also. Now we can eliminate this one also. This remaining three. This remaining this three. This two. You can only help to reduce some noise or notches or frequencies produced by the system. But these three will not helpful to minimize the lightnings or surge currents. Remember, this will only helpful for reduce the noises or notching or frequencies or high frequencies that is produced by the system. It can only helpful for this one, but the surge currents or the huge amount of surge currents is minimized by the surge arresters or utility surge arresters. You You can only for another devices to reduces the faults is like this. You can see this. You can see this. These are the some devices. Some you can only to minimize the diverted currents or noise or some frequencies. Okay, so these low pass filters and high pass filters, then this low impedance conditions or insulation transformers will not provide the will not the solution for the protection of the lightings. The surge resistors and the transients, voltage suppressors and utility surge resistors are main basic devices to minimize the surge currents. Remaining these three devices are used to reduce the noises or notchings or frequencies that produced by the uh, surge resistors. You know that why that problems are arising in the system because of the groundings all other things. Okay, okay. Now, next now, thank you for joining this one. The next class, we are going to discuss the another